This is a brief explanation on the perpendicular bisector. So let's say we have a triangle, and the first thing we need to do is find all the midpoints. So by checking the box, we're going to find all the midpoints of all the sides of the triangle. So which are these three dots? These 3 points on those segments. If we were to move it around, the dots move. Now we want to create a perpendicular bisector through each of those segments. So they should be a right angle coming out through that point, creating a 90-degree angle. And these are our 3 perpendicular bisectors for each side of the triangle. Now please notice that we ended up with a 90-degree. It shows right there, just to double check. So the intersection of all the perpendicular bisectors, it would be point G, which we see here. So let's just take one perpendicular bisector, and right now it's going to be H. So we have point G is the point on the perpendicular bisector, and it'll stay there. So as you can see, the intersection of all the bisectors was this point, but this point continues to be on the angle on the perpendicular bisector that we're going to be using. Now I want to draw the segments from point G to the endpoints of BC. So once I do that, their lengths come up. So by looking at these lengths, I have that I is 3.7 and J is also 3.7. Now it doesn't matter which of these little vertices of the triangle I move, they continue to have the same number. So the observation that we could see here is that the length of the segment BG, which is this one, is equal to the length of the segment CG. So these two segments are equal distance from point G because it's on the perpendicular bisector. And once again, you can move any of the vertices, and this segment is going to continue to be true. Thank you.